In this interactive simulation, we can see the relationship between the velocity of a wave, the wavelength, and the frequency. So the frequency is the number of times an object oscillates up and down per second. And so we have a little blinking light at the top that tells us the number of blinks per second in terms of how this is oscillating. We have in the simulation, I'm going to pause this for now, we have the frequency that's listed here, and then we can adjust the wavelength of the wave and the velocity of the wave. So we're going to start by adjusting the velocity. So I'm going to go ahead and hit play, and the velocity of this wave is 0.4 meters per second. And we want to keep the wavelength fixed, which is the distance between successive crests or successive troughs. And so let's see what happens to the frequency if we double the velocity. So it's at 0.4, we're going to make it 0.8, but let's go back actually. So it's at 0.4 and our frequency is 0.8. So as I increase the velocity and I double it so that it is now 0.8, I notice that the frequency is now 1.6, right? So the flashing here is faster. So the frequency has doubled. When the velocity doubles, the frequency doubles. So now we're going to keep the wavelength fixed, and we're going to decrease this speed from the speed of the wave from 0.8 down to 0.2. So we're going to decrease it by 1/4. Hit play. So now it's going slower. The wave is traveling slower to the right, and the frequency has also decreased. So when we decrease the velocity by 1/4, the frequency also decreases by 1/4. So we would say that the velocity and the frequency are directly proportional to one another. If you decrease the velocity, however much you decrease it, you also decrease the frequency. And if you increase the velocity by however much you increase it, you also increase the frequency in that way. So now we're going to keep the wave speed fixed. So I'm going to go ahead and I'm going to set it back at 0.4. And now I am going to have the wavelength set at 0.5. And I'm going to take note of what the frequency is. So here we go. So our frequency is 0.8. And now I am going to double the wavelength. So it was 0.5. I'm going to double it and make it 1. Whoops, went too far. There we go. And we notice that as we increase the wavelength, which is the distance between successive crests here, there's my wavelength, that as I double the wavelength, the frequency has actually decreased, and it has decreased by 1/2. So there's an inverse relationship between wavelength and frequency. As you double the wavelength, you decrease the frequency by a factor of 1/2. So now let's do the same thing again, and let's see what happens if I make this 2. Oops, there we go. It's hard to get it right on. Well, it's not wanting to go right on, I think, because my simulation is so small. But anyway, there we go. So now, again, I have doubled the wavelength once again, and the frequency has halved again, right? So it was 0.4, now it's 0.2. So there is this inverse relationship between the frequency and the wavelength.